Hello everyone. So in the last video I went through how to make a 1 to 2 encoder. And in this video I'm going to make a 2 to 4 encoder. So why is it 2 to 4? Well, it's because in binary, when you have 2 bits, you have up to 4 possible states. So say 2 bits here. We've got a 0 and a 0, 0 and a 1 and a 0 and a 1 and a 1. So these are our potential inputs, and let's just do this. So that's our input, and we want an output for each of these states. So we have 4 outputs. Well, it's 1, 2, 3, and 4. So it's output 0, output 1, output 2, and output 3. So when we was doing 1 to 2, we could just do this with buffers. But this is a little more complicated, as we can't just use a buffer on both bits, because then you still need to compare them in some way. So we have to use AND gates this time. But how would you still represent 0 here? Because 0 and 0 is still 0. So we actually want to invert all these as well. So we have our how should I lay this out? I'll do it up here again. So we have input 0 and input 1 here. So that comes down here, that comes down here. But in order to get to 0, in order to get this input, we actually needed inverted versions as well. So we'll shoot off from here and have some little inverters. So now this gives us something we can actually use. So 0 output 0 is when it's 0 and 0. To actually use that with an AND gate, let's build an AND gate here. We actually want to use the inverted ones, because those would be 1 and 1. And 1 and 1 is 1, so we'll get that. So let's do that. And that's our 0. Now all of these outputs will have an AND gate. I might not have left myself enough room to do this, but we shall squeeze it in somehow. So output 1 is this one. So we want the inverted output of input 0. So that we'll just do it like this. Could have probably just come down from there. And the regular input from output 1. So input 1. Like that, and that will give us our 1. Now for the third one, this is actually 2, because it was 0, 1, 2, 3. We want the regular input from here, and the inverted input from this one, as that will now be 1 and 1. And that will give us output 2. And in the final one, it's 1 and 1 should output 1. So that's just both of these regular inputs. Like so. And that's our 2 to 4 encoder. Now, something else I mentioned in the previous video, but I sort of cut out quickly, was something you can do with these when you're using AND gates, is you can actually add an enable line. So if you didn't want any of these outputs, you could disable the whole circuit. So actually what I'll do first is I'll draw this as a box diagram, like as a logical circuit. So we have our 2 inputs. This is input 0 and input 1. And we have our 4 outputs, 2, 3, 4. Okay. I won't label them, you know what they are. So if we wanted to add an enable, so when this is on, one of these is on. When it's off, none of these are on. So you can disable the output. Doing that when you have AND gates is quite easy. Pardon me. So we'll put our enable line down here. And all you do is connect it to all the AND gates. It's gone a bit messy now, isn't it? Squeeze that in there. So when that's true, one of these outputs will be true depending on the inputs. If it's off, these will always be off. None of these will come out true. So yeah, you can add an enable line, and I'll do that when I build this on the breadboard. So I'm not gonna draw the entire schematic here. Right, in the last video, I already built the inverter, so you know how I'm going to build that. But the AND gate, how do you build an AND gate? So what it is actually two resistors. So you need, well, if you're doing enable, it's actually three resistors, transistors. You need a transistor for each input. So let's just do one here. So this is going to be one AND gate. And we have our base, our collectors, and our emitters. Oh yeah, they have these little lines as well, don't they? There we go. Screwed that one up a bit. Okay, so to do an AND gate, we have VCC on one end. That goes from there. And these are actually all tied together. And at the end, we have a resistor, and that goes to ground. And these are all our inputs. So we'll just call this 0, 1, and 2. Now, the output of this is here. So this is our output. So what's happening is that when one of these is false, VCC is not getting through to here. But this is connected to ground, so it goes out like that. It's basically like a buffer, but you have 3 transistors in it. When all of these are true, so when all of these are high, VCC will be able to get all the way through it, and because of this resistor, it will prefer to go out here, so this will become high. So that's a 3 input AND gate, and we're going to need 4 of those. So let's do a quick bill here. So we have 2 transistors for the inverters, and we have 3, 6, 12, so that's 14 in total. 14 transistors, and so this will be a 1K. Actually, what you want here is also this will be a 1K. No, I've got that wrong. Sorry, we need resistors down here on the gates. So that'll be 3 resistors per gate, so that's 12 again. And right, just for 1K. So let's do 10K resistors. Let's plan this out a bit. So we need 12 for those. And I need 2 of those. That's 14 of those as well. And the 1Ks, so this is just for ground, it's 1, 2, 3, 4, 5, 6. So we only need 6 of those 1Ks. And 4 LEDs. And those will need 4 1K resistors as well, so that puts that up to 10. Okay, so that's all our parts, and I'll go through that now. Right, so let's build our 4 AND gates. So they're all tied together. Oh yeah, in the last video I actually made a little mistake. I said this way it's the emitter base collector. It's actually the collector base emitter. But these are bipolar transistors, so it doesn't matter. I mean, they won't perform in exactly the same way, but for 5 volts logic level stuff, it's the same. But yeah, try and make sure you generally get it correct. It's easy to forget. It really is. It's not like you can remember the pattern based on the side here, but remembering the order between emitter base collector or collector base emitter is just it's annoying. Right, that's all the AND gates finished. I'm going to test them quickly. And they've all got their LEDs. Just need a few jumpers. Okay, so we need a jumper for each input. So I'll just tie one of them low for now and the rest high. I'm only going to be testing this one at the moment. Let's turn it on. And if I turn this high, that should turn on. Yep. So yeah, that's definitely working. I won't bother trying testing them because they're all the same circuit. Do a quick double check. Okay. So that's our AND gates working. Now we need our inverters, which I'm going to put on the end here because I have a little bit of room there. Right, okay, so that's the inverters done as well. So let's try and wire these up. So, okay. So these should actually also be tied to our actual inputs. Actually, I'm going to turn these round because I'm just going to move these over here instead. Just so they're out of my way. Okay. So this goes to the inverted input. Oh, there you go. There goes the other one. So our actual inputs, see if we can grab some nice long cables here. Yeah, we have two orange cables. So these orange cables will be our actual inputs. And the inverted output, actually, oh wait, no, that's correct. So, right, I'm going to need to see this diagram now, because this is where it starts getting a bit, oh, wait, I did do that. Okay, no, that's fine. Right, okay, that should be everything. So, hold on, let me get this, that's pin, this is input 0 and this is input 1. Okay, right, we should be done. That's all the bits used. So we've got everything here. So both of these are tied low at the moment. Actually, let me zoom in a bit. Right, both of these are tied low at the moment. So this should be 1. It should be on, off, off, off. Hopefully it works. Hey, it does. Okay. So that works. Now one of these, like this should go to this one, I think. Oh no, that's not good. What's gone on there? That shouldn't be on. Only one of them should be on. Like this one. That goes to the third one. That I would expect. And this should be the fourth one. Okay, there's something wrong when you have this here. going on here? Okay, sorry I had to cut that. I had to really sort of knuckle down and work out what that was. And I found out what it was. Um, one of these resistors isn't actually a 10k, it's a 220k. No, sorry, just a 220 ohms. And that's what's causing the issue. So because it's got such low resistance, power is coming from here straight to that, like through other wires. So it's this one. So I'll turn it off before I take it out. It was this one. See, I've got, like, these were some of the original resistors I had, and like the barcode marking on resistors is pretty ambiguous anyway, but these colors are really faded. It's hard to actually read them. So here we go. It's over here. Grab an actual 10k out of there. Let's put that back in the actual 220 slot, and grab a 10k. This is why you need a multimeter. Problems like that, really easy to solve with a multimeter. Because I was looking at all the wires going, oh, maybe it's in the wire. Maybe I've wired something wrong. But no, I think the wiring is actually correct. It's literally just this resistor. So let's go through this again. Let's turn that off. Okay, so that's 0. That's correct. That's 1. So this should be 2. This is where the issue was. Hey, it works. And then this should be 4. Perfect. So that is our 2 to 4 decoder. That is this circuit with enable. So you can enable it or disable it, whatever. Yeah, that is this circuit. Let's just name that. Let's name that 2, 2, 4. These are inputs, and these are outputs. Right, thank you for watching, and see you later.